Here's a question where you are asked to rationalize the denominator. In other words, you have to get rid of any square root, or in this case, fourth root, that's in the denominator. So I need to find something to multiply both top and bottom by so that I get rid of the denominator. Since it's a fourth root, and since I only have one s here and one t, to get fourth root I need to have four things that are the same. So I'm going to multiply both top and bottom by, I've got one s already, so I need another 3. I have one t, I need another 3. If I multiply the bottom by that, I also must multiply the top by that. So on the top, 1 times that is this identity property of multiplication. It won't change it. So s cubed t cubed over, on the bottom, I'll have the fourth root of s to the fourth t to the fourth, because I have one s and then another 3, so that's 4 altogether. But the fourth root of that is just going to be plain old st. And then on the top I'll have this. I'd love to cancel something, but this stuff is under a square root, this stuff isn't, and so that would be my answer. Next question, same kind of game that I need to do with this one. I am going to split this up though, so I'm going to have a cube root of 4 on the top, and I'm going to have the cube root of 5x to the 5th y squared on the bottom. So with radicals, if you have the radical of a quotient, you can take the same radical with the same index of the top and divide it by the same radical of the bottom. Okay, so now I really forget about the top. So cube root 4, but it's the bottom that I need to multiply something by. Whoops, I extended that a little far. So I've got the cube root of 5x to the 5th y squared. So the question is, how many more 5's, x's, and y's do I need on the bottom so that I get them in groups of 3? Because that's my index. Okay, whoops, I don't need a equal sign there. So I need to times top and bottom by something so I get 3 of everything. So I have the cube root. I have one 5 here, so I need another 2 5's. I'll put a 5 squared there. I have 5 x's, so to get one more would give me 6, and that would be 2 groups of 3. So I just need one more x. Y's, I have 2 y's. I need 3, so I just need one more. So I'm going to multiply the bottom by that. If I multiply the bottom by that, I also have to multiply the top by that. So on the top, since they're both cube roots, I can combine them. So it'd be 4 times 5 squared is 25. 25 times 4 would be 100. X and a y. Over, on the bottom, I'll have the cube root of, now I have 3 5's, I have 6 x's, and I have 3 y's. So if I simplify the bottom, I've got this up top. Simplify the bottom. Cube root of 5 cubed is just going to be 5. Cube root of x to the 6th will be x squared. And the cube root of y cubed will just be a y. So that would be my answer. Notice no square roots on the bottom, and that's what I was going for. Alright, hopefully that helps.